compounds that are made up of two different non-metals that have electronegativity difference, right? Such compounds are called polar covalent compounds, right? And these kind of compounds that are composed of same type of atoms, right, that attract the shared pair of electrons equally towards one another, right? These two atoms, both these atoms will attract the shared pair of electrons with equal force, right? Same is the case here. These oxygen atoms, both oxygen atoms will attract shared pair of electrons with equal force. So these shared pair of electrons will lie at the middle, right? Hence no polarity would develop in these three molecules that are made up of same types of atoms. But it's not the case with HCl. So these are non-polar molecules, no polarities resulted, but this is a polar molecules because it, due to electronegativity difference, polarities has developed, positive and negative polarity, right? So these kind of compounds are polar covalent compounds, these kind of compounds are non-polar covalent compounds. So when combining atoms are identical, shared pair of electrons would remain at equal distance. Why at equal distance from both the combining atoms? Because both are attracting the shared pair of electrons with equal force. Polar covalent compounds, when combining atoms are different, like hydrogen and chlorine, combining atoms are different, the atom with large electronegativity value attract the shared pair of electron towards itself, acquiring slight negative charge, and the other will acquire slight positive charge, resulting into a dipole, like the molecule of hydrogen fluoride and hydrogen chloride, right? So now let's just quickly see the properties of covalent compounds. Since in all these we have seen that covalent compounds exist as molecules. This is an oxygen molecule, this is a nitrogen molecule, HCl molecule, right? So these all exist as molecules, whereas in case of electrovalent compounds we have seen that formation of electrovalent compounds resulted into positive and a negative ion. So positive and negative ion developed high force between one another, right? So in covalent compounds there are no ions, right? So there are only molecules, and we know between molecules the force of attraction is less compared to ions, right? So due to less force of attraction between covalent molecules exist as soft solids, liquids or gases, right? And on the similar reason, since covalent molecules have less force of attraction between them, these covalent compounds possess less boiling point, less melting point, right, and are volatile. All these properties. All this happens because of less force of attraction between the molecules and very less amount of energy is required to separate these molecules, right, to separate the binding between the molecules, right. Exist as liquids, gases, soft solids with low melting and boiling point due to weak force of attraction between binding molecules. Thus less energy is required to break the force of bonding, and they are non-conductors of electricity in solid, molten or aqueous state. Okay, for any compound to behave as a good conductor of electricity, it should have ions. Without ions, electrical conductivity is not possible, right? And we have seen in the formation of all these molecules that all these consists of molecules, right? There are no ions, right? So when these are dissolved in water solution, there would be no ions. These would not result into ions. These covalent compounds, oxygen, nitrogen, right, carbon tetrachloride, methane, right, all these are covalent molecules, and when they are dissolved in water, when they are poured in water, they won't dissociate into ions. They will exist as molecules. Since they exist as molecules, there are no ions, so no electricity would be conducted, right? Because of the absence of free ions, electricity would not be conducted because covalent compounds exist as molecules. right? This is the reason. And polar covalent compounds are also uh, polar covalent compounds are also soluble in water. We'll talk about polar covalent compounds, but first thing, these covalent compounds are soluble in organic solvents and insoluble in water. Why soluble in organic solvents? Because organic solvents are also exist as molecules. Since since organic molecules also exist as molecules and covalent compounds also exist as molecules, right? So we know that like dissolves likes, right? So covalent compounds dissolve in organic solvents, right? Covalent compounds are insoluble in water but dissolve in organic solvents because organic solvents are non-polar. They are non-polar and exist as molecules. So that is why they are soluble in organic solvents. And polar covalent compounds ionizes in solution, due to which they are good conductors of electricity. Since we said that non-polar covalent compounds are bad conductors of electricity. Why? Because they exist as molecules, right? There are no ions. But we have seen that in case of polar covalent compounds like HCl that we have described, the bonding in HCl, polar covalent compound HCl, when dissolved in water, it exists as ions. It breaks up into, or it ionizes in solution, in water solution. HCl ionizes into water solution, right? Let's just quickly see how it ionizes. We have already seen that HCl consists of a positive and a negative end, right? And we know that water is, we know that this is how HCl exists as, right? And we know that water also has a positive and a negative end, right? Water is also polar in nature, HCl is also polar in nature. That is why HCl dissolves in water, right, and exists as ions. Let's see how water will make, let's see how HCl ionizes in water. It will form ions in, HCl will form ions in water. That is why we say it ionizes in water. Since oxygen has a negative end, right, so this negative end of oxygen will attract this positive end of HCl molecule, which exists as dipole, and this positive end of HCl dipole is a hydrogen atom, right? So what it does is it will attract this hydrogen ion, or this hydrogen ion from HCl, right? So when it will attract this hydrogen ion, it will form this plus chloride ion, right? So what is this? This is positive. Positive has came from this positive ion of positive charge of this hydrogen ion from HCl. So this is nothing but hydronium ion plus chlorine. So HCl exists as hydronium ion and chloride ions in solution. Since we have ions in HCl solution, so when we pass electric current, due to the presence of these ions, HCl or polar covalent compounds are good conductors of electricity. Why? So since HCl has converted into or ionized into hydronium ion and chloride ions, right, due to presence of these ions, HCl is a good conductor of electricity in water solution, in aqueous solution, right? So this is important. We will simply write that due to the presence of ions, hydronium ion and chloride ion in water solution, HCl will act as a good conductor of electricity. And we have seen how the positive and negative ion were developed, right? The negative end of oxygen attracted the positive end of HCl molecule, right, and formed hydronium ion, positive hydronium ion, right? So I hope all this is clear to you. Let's just quickly take two more examples. we have said that covalent compounds that are made up of different non-metals, right, they will develop polarities, right, they are polar in nature, right. But let's take example of methane molecule, right. We know that methane, in methane, formula of methane is CH4, right. Let's see how covalent bonding gets formed in methane molecule. 1 2 3 and 4. Now since carbon has 4 electrons in its outermost shell, it needs 4 more electrons, right, to complete its octet, right. To acquire stability, carbon need 4 more electrons, right. So let's see how it will get 4 more electrons. This is hydrogen, and we know methane has 4 hydrogen atoms, right. And we know that hydrogen has 1 electron in its outermost shell. So each of this hydrogen atom will also try to acquire 2 electrons to become stable, and this carbon will try to acquire 4 more electrons. So what hydrogen will do, each of the hydrogen atom will share its electron with 1 electron of carbon atom. So it will share 1 electron with this carbon atom, 1 electron with carbon atom. Another hydrogen atom will also share 1 electron with carbon atom. This hydrogen atom will also share electron with carbon atom. So this will also share electron with carbon atom, right. So all these hydrogen atoms, after sharing 1 electron with carbon atom, has acquired 2 electrons. So all hydrogen atoms have become stable. Now since all these are shared pair now, right, all these 4 are shared pair, so this shared pair belong to hydrogen as well as to carbon. Now these shared pairs are common property of all the atoms in this covalent molecule. So since this all these shared pairs, 4 shared pairs, belong to the carbon as well, so carbon, now let's count with all these shared pairs since it belongs to carbon also. 1 2 3 4 5 6 7 8. So carbon has also acquired 8 electrons. So all the atoms in this molecule are stable, right. So this is how covalent bond formed between methane molecule. So but as we have seen that HCl has acquired polarities, right, because of electronegativity difference. Now in case of carbon and hydrogen, what is the electronegativity difference? Let's see. Hydrogen has electronegativity 2.1 and carbon has electronegativity 2.5. But since this molecule, methane molecule, is formed of different non-metals, carbon and hydrogen, but still it is not polar molecule. Why? Because electronegativity difference is very small, right. The electronegativity difference between carbon and hydrogen is very small. Carbon electronegativity 2.5, hydrogen electronegativity 2.1. Whereas in case of HCl it was 3.0 and 2.1. Electronegativity difference was high. That is why HCl was a polar molecule. But in case of methane, between carbon and hydrogen, electronegativity difference is very low, right. Since electronegativity difference is very low, this shared pair of electron was not displaced towards carbon atom, right. Since it didn't displace towards carbon atom because of low electronegativity difference, it remained almost in the middle, right. So that is why there are no charges that gets developed between carbon and hydrogen bond, right. So this short answer is methane molecule, although made up of different non-metals, is not polar because of small electronegativity difference between carbon and hydrogen atom. Due to small electronegativity difference, the shared pair remained almost in the middle of carbon and hydrogen bond, right, and is not displaced towards carbon, right. Now let's just see one more example of let's take example of ammonia. we know that nitrogen has 5 electrons in its outermost shell. Formula of ammonia is NH3. Let's see the formation of ammonia. So nitrogen needs, it has 5 electrons, it needs 8 electrons in its outermost shell, and we have 3 hydrogen atoms in ammonia, right? So hydrogen will try to acquire 2 electrons. So each of the hydrogen atom will share 1 electron with nitrogen atom. This will also share, right? So we have 3 shared pair which belongs to hydrogen as well as to nitrogen. So this hydrogen has, this shared pair belongs to this hydrogen as well as to this nitrogen. Similarly, this shared pair belongs to this hydrogen as well as to this nitrogen. So this all the 3 hydrogens have acquired 2 electrons after sharing. So all these hydrogens have become stable. Similarly, nitrogen, if we check 1, 2, 3, 4, 5, 6, 7, 8, since this shared pair belongs to nitrogen as well as all the 3 shared pair belong to nitrogen as well. So all these atoms have acquired stability, and this ammonia molecule is a polar covalent compound because of high electronegativity difference between hydrogen and nitrogen, right? So since there is high electronegativity difference between nitrogen and hydrogen, and electronegativity is nitrogen is high compared to hydrogen, so nitrogen will develop slight negative charge and nitrogen will develop slight negative charge, and all hydrogen atoms will develop slight positive charge, right? And since it is polar, when it is, this ammonia gas is soluble in water because it is polar covalent molecule. Ammonia molecule is, or ammonia gas is highly soluble in water, and it forms ammonium hydroxide when dissolved in water, right, creating ammonium and hydroxyl ions. Similarly, if we talk about one more molecule, it's carbon tetrachloride, CCl4. Right. We know that carbon has 4 electrons, 2, 3, and chlorine also has 7 electrons. So chlorine need 1 electron, and carbon need 4 electrons to acquire stability. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right. So chlorine will share 1 electron with carbon and it will form 8 electrons. Similarly, this chlorine will also share 1 electron with carbon and form 8 electrons. Same is with this and same is with this. So 4 shared pair of electrons are formed, right? And these shared pairs now belong to chlorine as well as to carbon. Now let's see how many electrons carbon has. Since these 4 shared pairs belongs to carbon as well, 1, 2, 3, 4, 5, 6, 7, 8. Carbon has acquired 8 electrons, so, and all the chlorine atoms 1, 2, 3, 4, 5, 6, 7, 8. Similarly 1, 2, 3, 4, 5, 6, 7, 8. Or chlorine atoms have also acquired 8 electrons. So all the atoms in carbon tetrachloride molecule has acquired 8 electrons, and hence all the atoms are stable. And we have 4 shared pair of electrons. And this molecule is also polar, is also non-polar. Why? Because of small electronegativity difference between chlorine and carbon. Electronegativity of chlorine is around 3.0 and that of carbon is 2.5. So electronegativity difference is less, due to which all these bonds are non-polar. All the carbon or all the CCl bond in CCl4 are non-polar because of small electronegativity difference. That is why we say that carbon tetrachloride is a bad conductor of electricity in solution. Why? Because in water solution, carbon tetrachloride does not dissociate or does not ionizes. Carbon tetrachloride in water solution does not ionizes, right? Because there is very low electronegativity difference between carbon and chlorine bond. right? Due to low electronegativity difference, there is no polarities develop, due to which no polarities means no ions in solution. No ions means there would be no electrical conduction in solution, right? So carbon tetrachloride in solution is a poor conductor of electricity because carbon tetrachloride exists as molecules, right? And there are no ions, right, in carbon tetrachloride solution. And we also say that carbon tetrachloride dissolves only in organic solvents, because organic solvents are also non-polar and CCl4 is also non-polar. So like dissolves like, right? So I hope all this is clear to you. Thanks.